Here in this video, we will be doing the exercise solving part for chapter 5 measures of central tendency for class 11 statistics. We start with the questions and answers of the exercises. The first question is, which average would be suitable in the following cases? The first case is average size of ready-made garments. So here for this, the answer will be the garment size are non-measurable or categorical data. The average mode determines the most frequent occurrences of garments. This helps the manufacturers and the production planners. If sizes are S for small, M for medium, L for large, XL for extra large, double XL for double extra large, M for median, then M is the most frequent occurred size, which is the average size. Here, mean is not suitable as there are no numerical values. Median can be used only when the sizes are in order. So, the most suitable average for this garment size of ready-made garments will be mode. Question 2 for question number 1 is average intelligence of students in a class. For this, the suitable average will be, answer is, the average intelligence in a class is calculated by the numerical scores provided. Intelligence score is a quantitative data. So here we take an example. Here the intelligence scores of students are 90, 88, 89, 99 and 100. These are the data values. And here we find the arithmetic mean by adding up all the intelligence scores of students and dividing by the number of intelligence scores. So here the arithmetic mean, which is come by the number of observations, by the total values of the observation adding up, divided by the number of observation, is 93.2. So this is the arithmetic mean or arithmetic average. So here arithmetic mean is the most suitable average to calculate the intelligence average of students in a class. We come to the third question of question number 1, average productions of factory per shift. For this, the answer will be the production per shift is a numerical value or the quantitative value which can be measurable. So here the arithmetic mean again takes the production of all the shifts and gives the total average output per shift. So here we take an example. Here if the production in the 4 shifts are as 500, 600, 400 and 700. So here what we do, we calculate the arithmetic mean for these 4 shifts production. So here we add up all the production of 4 shifts, which is 500 plus 600 plus 400 plus 700, and divide by the number of observations. So here again arithmetic mean comes up as 550. So the arithmetic mean is the correct average for this kind of average calculations. Now we come to the fourth question of question number 1, which is the suitable average for average wage in an industrial concern. So the answer for this question will be the average wage is the numerical, again the quantitative value or calculations of all the wages of the workers. So here again the arithmetic mean calculations of all the workers' wages is to be considered. Now we take an example here. So wages of 6 workers working in a factory and is calculated in rupees are provided. So what is it? 5,000 rupees, 6,000 rupees, 7,000 rupees, 8,000 rupees, 9,000 rupees and 10,000 rupees. Again we calculate the arithmetic mean by adding up all the values, which is 5,000 plus 6,000 plus 7,000 plus 8,000 plus 9,000 plus 10,000, and divide by the number of observations. So the arithmetic mean comes out to be 7,500. So here arithmetic mean is the correct answer to calculate the average wage in an industrial concern. Now we come to question number 5, which is when the sum of absolute deviation from average is list. So which average will be suitable? So here the answer will be absolute deviation is the numerical difference between the observation and the central value. So the median has the property that the sum of the absolute deviations of the observations from it is the least or the minimum. So here hence the median is the correct average. So median will be the right answer. Question number 6 of question 1 is when quantities of the variables are in ratios, so which average will be most suitable? Here geometric mean is the most suitable average for calculating for percentages, ratios, index numbers or growth rates. Now we take an example here. Suppose the ratio of product changes in 3 periods are 2:1, 3:1, 5:1. So the geometric mean is the cube root of these ratios. So 2 by 1 into 3 by 1 into 5 by 1. So it is cube root of 2 into 3 into 5. So geometric mean is taken out to be 3.1072. So hence geometric mean is the most suitable average for this quantities of the variables when are in ratios. Now question number 7 of question 1 is in case of open-ended frequency distribution. Here the answer will be in open-ended there is no exact value. The position of the observations in the distributions matters for calculations. So the extreme values in the open-ended frequency should not affect. Hence median is the most suitable average for in the case of open-ended frequency distribution calculations. The second question of this exercise is indicate the most appropriate alternative from the multiple choices provided against each question. So the first question of question 2 is the most suitable average for the qualitative measurement is. So here the answer will be what? It is mode. The next question is which average is affected by the presence of extreme items? Here the answer will be arithmetic mean or mean. It is affected by the extreme items. The third question is the algebraic sum of deviation of a set of n values from arithmetic mean is. Here the answer will be what? It is 0. So here we get all the 3 answers for question number 2. The third question is comment whether the following statement are true or false. So the third question, question number 1 is the sum of deviations of items from median is 0. So here the answer will be false, and the reason is as it is the smallest possible value compared to any other value. So here we find that the sum of deviations of items from median, it is not 0, but it is the smallest value, as sum is equal to what? Summation of xi minus of a, where a is the assumed mean or median and xi is the observation. So where a can be mean or median, so sum of deviation is the least value compared to the other values. So the answer will be false. Now question 2 of question number 3 is an average alone is not enough to compare series. So we will have to answer it is true or false. So answer is an average, mean, median or mode can only give the single representative value. It does not show the variation, stability or range of values. So here the statement is what? It is true. The third question of question number 3 is arithmetic mean is positional value. So the answer is arithmetic mean is a mathematical average and not a positional value. It is calculated using the formula x bar is equal to summation of x by n, where x bar is the arithmetic mean and summation of x is the observations and n is the number of observations. So here obviously the statement is what? It is false, as arithmetic mean is not a positional value. Now question number 4 of question 3 is upper quartile is the lowest value of the top 25% of the items. Here the answer will be when the data are arranged in the ascending order, it is divided into what? Into 4 equal parts. So these 4 parts are called the quartiles. That means from 0 to 25%, 25% to 50%, 50% to 75%, and 75% to 100%. These are the 4 quartiles. Now the upper quartile, which is Q3, are the marks, the points below which the 75% of the data is present. So the remaining 25% of the data lies above the Q3 or the upper quartile. Hence the statement is true. The last question of question number 3 is question number 5, which is median is unduly affected by extreme observations. So the answer will be median depends on the positions or the middle values. Median is not sensitive to the extreme values. Hence, the statement is false. So here we end up with all the 3 questions from the exercise of Chapter 5, Measures of Central Tendency. Hope you enjoyed. Thanks for watching. Click on the subscribe button for more videos on this chapter and on statistics for class 11.